Application layer or physical layer? No, not application, not physical. It depends, right? It depends on devices. Like we are talking about the sender devices or receiver devices, right? On the sender devices, on a sender machine, first layer will be what? Application layer, correct. And at the receiver machine, correct. So let's say I have two computer, computer A, computer B. So when computer A will generate data, it will generate at which layer? At application. Then it will hand over to presentation, then session, then transport, then network, then data link, then physical, right? Like my OSI model will flow from application layer to physical layer, and at physical layer this device is going to add the data, correct? When computer B will receive it, it will receive at which layer? At physical layer. Then it will hand over to data link layer, then to network layer, then to transport layer, then to session layer, then presentation layer, and then application layer. So here OSI model is going to flow from physical layer to application layer, correct guys? Any question in this process? Hope this process is clear to everyone, correct? Now what is the function of application layer? Tell me guys. Correct, interface between user and actual application, right? It's provide a user interface. Guys, I'm requesting to everyone to speak. See, if you will not participate, I'm damn sure you will not learn. If you want to learn, you have to participate. It doesn't matter you are right or wrong. Really, it's not matter, right? Matter is only you are participating or not, you are speaking or not, you are communicating or not, right? So application layer is responsible to provide a user interface between user and actual application. Let's say I want to access the Google server. So I need a browser where I can type www.google.com. My browser can be what? Chrome, Mozilla Fire, UC browser, Opera, right? Again, if I want to send a mail to my friend, I need an interface. If I want to send a message on WhatsApp to my friend, I need an interface, right? So those application like WhatsApp application, Chrome, UC browser, Gmail, these are what? These are application layer. Correct guys? Then what is the function of presentation layer in OSI model? Presentation layer. Application layer provides a user interface between the user and the application. Let's say you want to access Google, web page of Google, right? So you need what? You need one interface where you can request for Google server, right? Let's say this is your computer in your home, and on the internet you are connected with internet, and on the internet there is somewhere Google server, correct? Through internet you and your device and Google server both are connected with each other. On this server services are running, right? Or let's say one service HTTPS is running, correct? So if you want to access this service from your computer, right, you cannot access this service directly. At least you need an interface. Like if you want to ping the server, you can ping through CMD. So CMD is also what? One application. You can type www.google.com in the browser, right? So your browser is what? Application. Right now you can see here on my screen, there is Google Meet, right? This is classroom of Google Meet. So how you are interacting with me, with the with this meeting room, with the help of this interface, correct? So application layer is responsible to provide you this interface, guys. This interface, right? Like here you can see this is what? Yeah.
Means we can say the software which are we are seeing in the
Which is
application.
interacting you with actual software, with actual application. The application which is interacting you with actual application, that is called application. Application layer, you can say, right? So again, this is what one interface. Through this interface I can access any server like Facebook server, Instagram server, Google server. So this interface is because of guys OSI model, right? Clear now?
Yeah.
Now to access the services, right, to access the application layer services, you need a protocol as well, right? So can anyone tell me at least 5 protocols of application layer which works at application layer?
HTTP, HTTPS,
HTTP, HTTPS,
email,
email, then
telnet, SSH.
yes, telnet. As a network engineer, telnet, SSH, HTTP, HTTPS, these are very important for you. SSH, then
FTP, TFTP.
correct, FTP, TFTP, DHCP, DNS, right? These are application layer protocols. So we are going to use these protocols to access services. Like in my company, there are lots of branches, and main data center is centralized. Let's say in Mumbai or in Bangalore, right? In the Bangalore center, lots of network engineer there who is monitoring the entire network, right? So there are some routers in Delhi, there are some routers in Mumbai, right? And they don't have network engineer there on Mumbai side or on Delhi side. Your company can manage these devices, these networking devices from a centralized location, right? From this Bangalore location, you can modify the configuration of device, you can change the configuration of device, right? So guys, this is what one kind of access. Which type of access? Remote access of networking device. Remote access of networking devices. And again, to access this, to use this service, you have to what use protocol, and that protocol can be what telnet or SSH.
SSH.
In the same way, if you want to transfer file between two devices, right? So transferring file or downloading a book from a server is what one kind of service. Again, to access this service, you need a protocol. That protocol can be what? FTP or TFTP, right? Okay, leave these protocols for now because we are going to discuss these protocols in detail. For now, presentation layer. Presentation layer is responsible for what? For
To present the data which will.
correct. To present the data means this layer is responsible for encryption, decryption, compression, decompression. Yes or no? For these kind of work. Then guys, session layer.
Uh,
Session layer is responsible to create the session, maintain the session, right, and terminate the session. And which engineer works on these three layer, on upper three layers?
developer.
Developers, software developers, software tester. As a network engineer, what you need to learn in these three layers is application layer protocols only. You need to learn only application layer protocols over here, right? That's it. Then your actual work is starting from here, from the transport layer. So now tell me at least 4 function of transport layer, like
So,
transport. Yes.
here in transport layer we will use two protocols.
Okay, we are using two important protocol over here, TCP and
U- UDP.
okay,
Uh,
that's good.
the the TCP is connection oriented protocol and UDP is connection
List protocol.
less.
Okay, this one is reliable. This one is TCP is reliable. UDP is unreliable. TCP is slow. UDP is fast. Then
TCP
sequencing.
required.
Yeah, sequencing is not required, is not happening in UDP. Sequencing is happening in TCP. There is windowing concept in TCP, but windowing concept is not in UDP. So these are, guys, what difference between TCP and UDP, right? So if someone will ask you like what is TCP and UDP, or tell me the transport layer protocol, then you can say there are two protocol. But what I am asking, what about the transport layer? I'm not talking about the protocols. Like these are protocols at application layer. But first we discussed what is the use of application layer? Like that I am asking you what is transport layer. Then we will come to protocol. But your answer is really good, right? At least you know this, that there are these two protocols work at transport layer. These two protocols are very important for network engineer. All network engineers should master these two protocol. Okay, like guys, transport layer is responsible for dividing a large size of data into a smaller part of data, because as I told you in last class that application layer don't have any foundation. It can generate any size of data, but transport layer, at transport layer we have what flow control. Miss transport layer have to check what is the minimum MTU between source and destination. According to that I will decide what should be the size of my segment. What should be the size of my segment? Okay, so first function of transport layer is dividing large size of data into a smaller part of data. Why we need to divide the large size of data into a smaller part of data? Because what I'm saying, application they don't have any foundation. It can generate any size of data. But if a device, let's say a router, is receiving a data right on this interface, and this router need to forward the data from this interface, and MTU of this interface is 100 bytes only, and it is receiving 200 bytes of data, then what will happen in this scenario? It is receiving 200 bytes of data, but this router don't have capability to transfer 200 bytes of data from their outgoing interface. So first receiving sending machine, sender machine have to check what is the minimum MTU between source and destination. According to that, I will decide what will be the size of one data. Correct? Then what you can say, transport layer is going to decide your communication is going to be happen reliable or unreliable, connection oriented or connection less, will there acknowledgement or not. Correct? And then there are two important protocols are working, that is TCP and UDP. Again you can say transport layer is responsible to add source port and destination port. Transport layer provides information about the port number. And what is port number? All the application layer services. See, to identify all the services at application layer we are using a unique number, and that unique number is port number. Means each service at application layer will have what? Port number. And guys, there are two types of port number. One is well known and another one is unknown. Well known means the port number which we have already defined to protocol, right? I'm talking about the application layer protocol. And where unknown port numbers are free, that we can use as a source. Correct? Clear to everyone? What is the range of well-known port number? 0 to 12, sorry, 1024. Correct. And range of unknown port number is 10252 to 65535. Very good. Okay, then guys, network layer. Now what is the responsibility of network layer?
Logical address
Yeah,
source to destination.
providing logical address, right? Means providing source IP address and destination IP address. Then data link layer, responsible to provide MAC physical address. Like network layer is responsible to provide logical address, data link layer is responsible to provide physical address. Physical address means your MAC address, right? So data link layer is going to add source MAC and destination MAC. Then guys, physical layer. Physical layer means what? Your cables. And what is the function of physical layer?
It physically connect to device.
Okay. See, physical layer is going to convert your frame at data link layer. What we call to data frame. Yes, frame to bits.
Bits.
Other function of physical layer can be what? It is going to sense the link. That link is working fine or not. Let's say I have two computer 1 and computer 2. Both are connected together through one Ethernet cable. So on both devices, OSI model is working. So physical layer is sensing this link also, like that link is working fine or not. If this link is not working fine, then devices are not going to share the data over here, going to not transmit the data over here, right? So let's say if this side, if cable is cut, right, or this port is down, automatically this PCA will sense that this link is not working fine. Line protocol of this interface will goes down, right? We will discuss that, don't worry. What is line protocol? So physical layer is sensing that cable as well, like link protocol, but line protocol, that line protocol is up or not, right? Now question is, okay, transport layer is responsible to add source port, destination port. Network layer is responsible to add source IP, destination IP, and data link layer is responsible to add source MAC and destination MAC. Correct. How? Question is how? Question is how? So how, guys? With the help of headers. With the help of headers. So now question is, what is header? Header is just extra information. What you can say? Header equals extra information to send the data to correct destination device, to correct destination. Let's suppose, let me give you one example of it, because header is very important and we are going to talk about the header in entire CCNA course. So see, let's say you are going to send one letter to your friend, right? So first of all, you will write down the letter on a page. Am I right? Then guys, after that, can anyone tell me the process? How I am going to send this letter to my friend? Recording is already in process, brother. Don't worry. Yeah, it's started. Fine. So see guys, to send this letter to correct people, right? If you want to send it to friend, right, you will never want to, that this letter should be received by anyone. You will always want that letter should be received by my friend only. For that, you know what you are going to do? You are going to put this letter in one envelope. Correct? In an envelope. Correct, guys? And on the envelope, you are going to write some information, some extra information. This is not regarding the letter, right? This information is only regarding to send it to correct people. What you are going to provide? Source address. Correct? Then what you are going to provide? So destination address, right? You will say your phone number here, phone number of your friend, like this. So this envelope is what? This envelope is nothing but your header. Header. Guys, with the help of header, what we did, we add some extra information. Why we have added some extra information? So that I can send this letter to actual people, right? To actual person. Correct? Am I right? Everyone? Am I right?
Yes.
If you will send the letter directly, right, it's not possible that your friend is going to receive it. Not possible at all, because address is required, right? But in the actual information, is address required, guys? No, right? We have added the address just to deliver it to correct person. In the same way, whenever my PC or whenever my browser or any application is going to generate a data, let's say this is my PC. Whenever this PC is going to generate a data, this data needs some extra information, right? Because here in the actual data, right, this is message. It can be, hello, how are you, brother, I love you, like that, right? But to send this data to a correct machine, to correct destination, we have to add extra information, and that extra information are source port, destination port, source IP, destination IP, source MAC, and destination MAC. Now who is going to provide these information, guys? Source port, destination port,
local
transport layer, right? Who is going to provide these information? Source IP, destination IP, network layer. And who is going to provide this information?
Italy.
Data link layer, right? Now let's understand the another important terms in networking, that is encapsulation and decapsulation. Encapsulation and decapsulation. Now, what do you mean by encapsulation? Encapsulation means adding extra information. Clear? And then decapsulation. Decapsulation. Decapsulation means removing extra information. Like in your letter, extra information is what? Source address, destination address. Where is that address? On the envelope. See, this is my letter, and then we have envelope, right? We have put it the letter in the envelope, and on the envelope there is source address and destination address, right? Then we will send it to my friend. My friend is going to receive the entire things like letter as well as envelope. But you know, my friend need what? Letter that is inside the envelope. So my friend is going to first check the destination. If destination is me, then I have to remove this envelope, correct? Your friend is going to remove it, and then it will pick the actual data. So this time, see, sender machine is doing what? Encapsulation. It is adding extra information, correct? And receiver machine is doing what? Decapsulation. It is removing that extra information.
Removing the information.
Clear? Is it clear? So your next topic was encapsulation and decapsulation here, right? And hope now encapsulation and decapsulation is clear to you. See, if I have two computer here, let's say two server, one computer and one server, suppose one server. This is Google server. MAC address of this machine is 0A, MAC address of this machine is 0B. This is, let's say, what? Google server, google.com, right? So guys, in the browser, if you will type www.google.com and once you will hit enter, your machine is going to generate a data for Google. At which layer? At application layer. Why? Why? Because to access the web page, we are using which protocol? HTTP protocol. And HTTP protocol works at which layer? Application layer. Whatever protocols run at which layer, guys? Network layer will generate traffic at network layer only. Whatever protocols are running at transport layer will generate their traffic at transport layer only. And whatever protocols are running at application layer will always generate their traffic at application layer only. Like TCP. TCP is going to generate their all messages at transport layer. You know what is SYN message? SYN message is nothing but TCP header. Yesterday we discussed SYN message in three-way handshake, right? Sender machine will first send SYN, then SYN plus ACK, then ACK. So this SYN message is nothing but TCP header only, right? So TCP protocol is going to generate this SYN message. At which layer? At layer 4, not at application layer. So don't think like all data in the networking is going to be generated at application layer only. Here, if you are typing www.google.com in the browser, definitely your data will generated at application layer. 1 minute. Next thing. Now application layer is going to hand over it to whom? Presentation, then session. We are skipping these two layers, right? Because you guys are network engineers and you don't need to learn presentation and session layer. So now when transport layer will receive this data, right? This is at application layer and transport layer. What transport layer will do? It is going to add extra information. In that extra information, what will be the source port, random port number, let's say 1024, sorry 5, right? And then destination port. What is the port number of HTTPS? 443. So destination port is going to be what? 443. Let's say IP address of this machine is 10.1.1.1. IP address of this machine is 10.1.1.2. Then guys, transport layer will hand over it to network layer. Network layer will do what? Network layer is going to add source IP and destination IP. Source IP will be 10.1. Destination IP will be, let me write like this. Yes, source port will be the random port number, that is 1025, let's say, and destination port is 443, will known port number. Then network layer is going to add source IP, destination IP, source IP 10.1.1.1, destination IP 10.1.1.2. Then data link layer is going to add what? Source MAC, destination MAC. Source MAC will be A, destination MAC will be what? B. So this process is called what? Encapsulation. Am I right? When receiver machine will receive this data, right? It will receive like this: 0A source MAC, 0B destination MAC, right? Then data link layer is going to remove this header and it will put the rest information to upper layer. 10.1.1.1 is source and 10.1.1.2 is the destination, right? So receiver machine have first remove this header, right? The first header, and then network layer is going to remove this header, right? It will put the rest information to upper layer, source port, destination port 443, and then actual data. Again transport layer will remove this header and it will hand over actual data to HTTPS protocol at application layer. So this time this process is called what? Decapsulation, because receiver machine is removing all the extra information that sender machine have added. Correct. So encapsulation, decapsulation. Hope it is clear to you. Now let's move to the headers, like what informations transport layer or TCP protocol, UDP protocol, IP protocol at network layer are going to add with data. See, okay, this is TCP IP model. Hope this is also clear to you. Now TCP header, because yesterday we discussed this one also. Now TCP header. See guys, inside the TCP header, how many information will be there? There will be what? First information is source. Second information is, third information is, and you know very well what is the use of sequence number over here, right? So that receiver machine can arrange the data in actual sequence. Am I right? Then acknowledgement number. Hope this field is also clear to you. Because as TCP is reliable, receiver machine have to send the acknowledgement. How it will send the acknowledgement? With the help of this field, right? We will see. Then guys, we have what? Header length. What is the length of this header? Then there is one reserve field, flag fields, window size. You know the window size very well. Checksum and urgent point. See, flag, reserve, checksum and urgent point. I will discuss these points later. For now, source port is clear, destination port is clear, sequence number is clear, acknowledgement number is clear, header length is clear, and window size is clear to you. Yes or no? If any question in these terms, guys, please let me know. Otherwise, now I am going to show you how TCP header look likes. Yeah, sure. See, acknowledgement number means, you know what? See, I have two computer, A, computer B. computer A is going to send one data, let's say data, this is data, and sequence number over here is 1. So when receiver machine means computer we will receive this data, computer B have to generate what? Reply, right? So it will give reply to acknowledgement number what? 1. Okay, then computer A will send their next data, wait a second, with sequence number 2. Again receiver machine will give acknowledgement on acknowledgement number 2. Yes, now you can ask. Anyone else?
Sir,
Yes.
I want to ask the TCP header. What is this? Why we are?
Why we are using it? Good
Yes.
question. Good question. See, brother, this is my server. Single server. On this single server, I am running lots of services like HTTP services running, HTTP S services running, and DNS services running, DHCP services running over here. Let's say these services are running over here. If this server IP address is 10.1.1.1, if this server is receiving one data, right? Which type of data? Application layer data, like HTTP data, right? It is receiving one HTTP data. Fine. It will receive at which layer? First of all, tell me this. This server will receive this data at which layer? Physical layer?
Presentation.
Physical layer, brother.
Correct.
Physical, right? Then it will hand over to whom? To data link layer.
To data link.
Data link layer will verify the destination MAC address, correct?
Yes.
Then it will hand over to whom? Network layer. Network layer will verify what? Destination IP address. If destination IP address will match, then it will hand over to what? Transport layer.
Transport layer.
Now how transport layer is going to identify the data, that this is HTTP data, or this is HTTPS data, this is DNS data, this is data of DHCP? How? So transport layer means TCP protocol or UDP protocol need what? Destination port number. So in the data there will be destination port number, guys, that will be 443. So when transport layer or TCP protocol will see this field that destination port is 443, that means, oh, this data is for what? HTTPS. So transport layer responsibility is what? Adding source port, destination port, and removing source port, destination port at the receiver machine. At the sender machine it have to add source port, destination port. At the receiver machine it have to remove source port, destination port. And to add this extra information, my devices are using what? Header. To add this extra information, my devices are using what? Header. This is the reason, guys, why we have header. Is it clear now, Sachin?
Yes, sir.
Header means what? Just extra information, right? Not related to actual data. This is just to deliver this data to correct machine. That's it. That's why first receiver machine is removing these all extra information. Fine.
Okay.
Okay. If you want to know, yes, Kapil, go ahead. Okay. Yeah. Yeah, correct. To send the response, again same thing will happen, right? To receive or to send, every time machines are going to perform encapsulation, decapsulation for each packet, for every packet. Without encapsulation and decapsulation, right, data transfer is not possible. Yeah, machine will have record that I am receiving this request from whom? From 10.1.1.1. So I will send it to 10.1.1.1. See, in the request, if source port number is what? Source port number is 1025 and destination port number is what? 443. Source IP is 10.1.1.1, destination IP is 10.1.1.2. Source MAC is 08, destination MAC is 0B. If machine is receiving this data, right? So when that machine will generate reply, it is going to put source what? 443, destination what? 1025. Source IP 10.2, destination IP 10.1. Source MAC 0D, destination MAC 0A. So yes, machine will have information, right? And this there will be many more, things is happening, right, that we will discuss. Like you can ask that how data link layer will understand that to whom I need to hand over at network layer, because at network layer also there are multiple protocols. Like when network layer will receive the data, how network layer will come to know that I need to hand over the data to TCP or UDP at transport layer. Both protocols are working at there, right? So this can be your question. Okay, we will discuss these all, don't worry. For now, headers is clear or not? Encapsulation, decapsulation, headers, these terms are clear to you or not? Good. If you want to read more about these fields, so guys, here I have mentioned, one short explanation as well for each field. Like you can say source port, it is a 16 bits value that specify the port number of sender. Destination, it is a 16 bits value which specify the port number of receiver. Sequence number, a number used by TCP that puts the data back in the correct order or can retransmit the missing data during the process called sequencing. Acknowledgement, the value in TCP octet that is expected next, right? See, I have computer 1, computer B. I'm going to send one data here from computer A to computer B, right? And this is, guys, TCP based communication. Okay, so here sequence number is 1. After sending this data to receiver machine, sender machine will start expecting one acknowledgement. It will start expecting acknowledgement, and receiver machine is going to send acknowledgement on sequence number plus 1. Sequence number plus 1. So what will be the acknowledgement number over here? Sequence number in the data was 1, a plus 1, 2. So when receiver machine will receive acknowledgement with acknowledgement number 2, machine will understand two things. First thing, that receiver machine have received my data, and receiver machine is requesting for next data whose sequence number is what, 2, right? So acknowledgement number, yeah, acknowledgement number is telling to device about the next data as well, that send me the next data, right? Receiver machine is saying send me the data with sequence number 2, you have sent me the data with sequence number 1. Jump file means, yeah, anyone can explain this, what he's saying?
I said jump a bit.
Okay, leave. Okay, so like let's say here we are using what, windowing. So in windowing what will happen, both machine is going to decide one window size, sender and receiver. Let's say window size between sender and receiver is what, 100 bytes, and this sender machine need to send 500 bytes of data. Transport layer have received 500 byte of data from application layer, let's suppose. So transport layer is going to divide it into how many parts? In 5 parts. 1, 2, 3, 4, 5. On each segments it is going to put one sequence number. Let's say sequence number 1, 2, 3, 4, 5, right? And guys, let's say 600 bytes. There is one more packet segment with sequence number what, 6. So as window size is 100 bytes, as window size is 100 bytes, after what number amount of data sender machine will expect acknowledgement, guys? See, there is mistake, some mistake, let me correct it. Window size, as window size is 100, so let's say I have a data of 600 bytes. this is what window size. Window size is not, let's say, what, 100. Window size is, let's say, 300 over here. Yeah, no, it's correct. Okay.
Sir, what is window size method?
Window size, window size is a technique to reduce the number of acknowledgement, as TCP is a reliable protocol. So receiver machine have to send acknowledgement after every segment. But if receiver machine will send one acknowledgement after every segment, then communication is going to be very slow. So that's why we come up with windowing technique. With the help of windowing technique, we are going to reduce the number of acknowledgement to make TCP process faster. How? Both machines are going to negotiate one window size on the basis of what, guys? On the basis of MTU, buffer memory. On the basis of buffer memory, we discussed in last class. On the basis of buffer memory, both devices are going to decide one, negotiate one window size. So window size is 300 seconds. Means now sender machine will expect acknowledgement after sending 300 bytes of data. What I'm saying? Sender machine is going to expect acknowledgement after sending 300 bytes of data. Means it is going to send first packet without acknowledgement. Yes or no? It is going to send second packet without acknowledgement, third packet without acknowledgement. Now sender machine have sent it 300 bytes of data, right? Now sender machine is not going to send any more data before acknowledgement. Now it is expecting what? Acknowledgement. Okay, and let's say due to congestion on the link, receiver machine have not received this data, right? Data with sequence number 2. Then my receiver machine is going to give acknowledgement on what? Acknowledgement number 2. It means send me the data with sequence number what? 2 again. Getting my point? If receiver machine is sending acknowledgement on 4 means what? Sequence number plus 1. Sequence number of last packet is 3, means 4. When receiver machine will receive this acknowledgement, it will came to know that, okay, receiver machine is requesting for which segment? 4th segment. That means receiver machine have successfully received these 3 segments. Yes or no? This is how acknowledgement and sequencing is working. Hope it is clear now. If yes, please let me know. Okay. Now the header length. It is the size of TCP header which indicate where the data begins. Like, guys, I have a data. This is my actual data, 100 bytes of data, right? And here I'm going to add one header. That is what TCP header, let's say, right? So I have to tell receiver machine that, brother, in the entire information, 20 bytes are header. So please remove 20 bytes last information. Am I right? Getting my point? So that's why we have header length here. So header length is going to tell to receiver machine that what is the length of header. Okay, so see, it is the size of TCP header which indicate where the data begins. Let's say my actual size of data is what? 100 bytes, and the header length is what? 20 bytes. So what is total length, guys? Total length is 120. How receiver machine will came to know that first 100 bytes are data? In the header there will be one information, right? Header length. That header length of this header is what? 20 bytes. So receiver machine will came to know that 100 bytes are actual data. Clear? For now, see, reserve field is always set to 0. Always set to 0. And flag fields, it is a control function in which is used to set up and terminate the session. Session means what? Three-way handshake. So flags are used to establish a connection or to terminate a connection. Like, guys, SYN. SYN is what? One kind of flag. SYN plus ACK means ACK is what? One kind of flag. FIN is what? One kind of flag. We discussed yesterday these 3 messages, right? While establishing connection and while terminating the connection. So SYN message is nothing but SYN bits on flag TCP header. SYN message is nothing but where you will see, in lots of books you will see this diagram. there will be three message. First message SYN message, then SYN plus ACK message, and then ACK message. Yes or no? In all CCNA books, you will see this diagram, brother. And most of the people don't know what is this SYN message. So SYN stands for synchronization message. This is nothing but a TCP header with SYN flag on. In the actual data, SYN flag will be what? Off. So SYN message is SYN bits on TCP header. That's it. SYN plus ACK message means what? It is a TCP header with SYN bits plus ACK bits on. And acknowledgement message means what? It is TCP header with acknowledgement bits on. FIN means what? It is a TCP header with FIN bit on. That's it. The next field is buffer size. This field negotiates the buffer memory of the interface. Checksum. This field is used to find error in TCP header. Right? So guys, you know how checksum is going to work. See, whenever a sender machine is going to send the data, right? Send the data. What this machine will do, let's say this machine is going to send data. This data is, let's say, hello. This sender machine is going to run one algorithm on this data, right? Again, we have multiple algorithm, right, for checksum, for generating a hash value, right? So let's say I have one algorithm here, like this is my algorithm. Algorithm is like, you know, juicer. In a juicer, if you want juice, what you have to do, you have to put the oranges, apples, yes or no, then you can get the juice over here. Algorithm is same thing, right? In the algorithm, what we are doing, we are putting the data and then we are generating a hash value. We are generating a hash value. Let's say this, in this algorithm, I have put the data. My data is what? Hello. So this algorithm is going to give me a hash value. Let's say hash value is what? ABC 1 2 3, like this. This is my hash value with this data. And same algorithm receiver machine have also, right? So when receiver machine is going to see, sender machine have first calculate the hash value and then it is going to put it in data. A B C 1 2 3 is my hash value. Same thing when receiver machine will receive the data, it is also going to put the data in the algorithm. Data is what? Hello. It will also calculate same hash value A B C 1 2 3. Now receiver device is going to match my hash value and the hash value coming in packet is same or not. If both are same, that means everything is fine. But guys, let's assume there is some attacker on the link between PC1 and PC2. There is ISP. On the ISP there is one attacker. Attacker have changed the actual information. Actual information was high, right? Attacker have changed it to buy. Attacker have modified the data to buy, and then it have sent it to receiver machine. Now receiver machine is clever, right? It is going to put the data in algorithm. It will calculate different hash value because data is different. Receiver machine will came to know that, oh my god, this data is modified, not original, please discard it. Getting my point? Like if you are transferring $100 to your friend, right? No one can modify the amount in between you and your friend device. No one is going to set it to $200. Because of what? Because of hashing. So checksum is similar like this. Checksum field means in the TCP protocol is going to run one algorithm to calculate the hash value, and it will add that hash value in checksum field. So that's why you can see in the TCP header we have one checksum field also. Yes or no? Right? If any flag will be on, so you will see that flag under this field. Reserve is will be always 0 for you. Now header length is clear, window size is clear, and urgent point, see the use of urgent point also over here. Urgent point, it is used to send data urgently. So this is part of quality of service. In CCNA you don't need to learn this point, right? In CCNP you have to learn it. For now you can skip, like, you know, in CCNP, brother, you have to learn the flags in very details. For CCNA this is sufficient, more than sufficient, right? But what I am saying again, while discussing the packet flow, or whenever I will capture the data, we will discuss more about the flag. And guys, now before discussing anything else, I want to show you TCP header right on the link. So what I'm going to do, I'm going to create one a small topology in GNS3. See what I will do. First of all, let me tell you what I'm going to do. I'm going to connect two devices together. Let's say one PC and one router. From the PC, I'm going to send some TCP data, right? And I will capture this link. I will capture this link. And in the capturing, I am going to open the data and then I am going to show you the TCP header. Fine? Clear? So let me give one name to this. Let's say test 1. Okay, no, I don't need to update it. Let's say this is my router and I have one PC here. Let me take router, but I will change the symbol. If anyone don't know how to use GNS3, guys, don't worry. I will tell you. This is my, let's say what, PC. Let me rename it to PC1. And this is my, let's say, server. Which server? Let's say router. It is router and Telnet service is enabled over here. Which service? Telnet service. Telnet is used to access networking devices remotely, correct? And Telnet is TCP based protocol. So whenever this PC will try to access R1 remotely, first TCP protocol is going to establish a connection, correct? And after that, PC is going to send actual data of Telnet, right? And guys, in the actual data, first of all, connect it. Yes. Here, let's say IP address is, what IP address you want to use over here? Tell me. Till now, we have not discussed IP addressing, so let me use the simple one, 10.1.1.1/24, and the router IP address is, let's say, 10.1.1.2/24. Okay. Now, if I want to telnet R1 from PC1, first of all, what will happen, guys? PC will generate what? TCP SYN message. Am I right? To establish logical connection, it will send what? SYN message. In the SYN message, what will be source port number? Hello? 1025. Any random port number will be there? Anything? And destination port will be what? Port number of? Not 443 is the port number of HTTPS. Port number of Telnet, guys, 23. 22 is SSH, right? Then network layer is going to add what? Source IP. Source IP will be what? 10.1.1.1. Destination IP will be what? 10.1.1. Then there will be source MAC and destination MAC, right? After sending, first PC is going to send this message, then R1 is going to send which message? SYN plus ACK, correct? Correct, guys? Yes or no? Tell me. ACK. Source port will be 22. Source port will be what? 22, because this time who is sending the data? Telnet protocol. And destination port will be what? The random port number. 102566, let's say. Source, okay. Source IP, destination IP will be 10.1, source IP will be what? 10.2, right? And then source MAC will be there, destination MAC will be there. Then this machine PC is going to generate which message? ACK message. PC is going to generate which message? ACK message. Acknowledgement, right? So till here, guys, any confusion? Anyone have any dot in this? This is for TCP connection. First message, First message, second message, and then third message. After that, between PC and router, there will be what? One TCP connection. TCP connection. And our process is called what? Three-way handshake. Yes or no? Then now TCP connection has stabilized. So now PC is going to generate what? Actual data of telnet. Which data? Telnet data. At which layer? At application layer. Then it will hand over to again transport layer. This time transport layer is going to add TCP header, right? TCP header with SYN bits off, right? There will be source port number, again the random port number, and destination port number will be what? 22. Source IP is going to be same 10.1.1.1, destination IP same, right? Then receiver machine will generate what? Telnet reply message. This is telnet request. PC is going to send telnet request, and then server is going to send what? Telnet reply. Source port 22 random, destination port random, like this. Fourth packet. Is it clear? Now see, first of all I'm going to access these devices. So to access these devices, simply I will double click over here and I will double click over here. Right now I have access of both machine. Now don't worry about the configuration. What configuration I am going to do? I am going to teach you these all things. Don't worry. For now, just forget about it. No IP routing, interface fast Ethernet 0/0, say no shutdown, and IP address is 10.1.1.1, 255.255.0. Exit. So IP interface brief exclude unassigned. So IP interface brief, okay, and so IP ARP, fine, clear. On router number 1, config T, interface fast Ethernet 0/0, say no shut, and IP address is 10.1.1.2, 255.255.255.0. Exit. Line VTY04 and say no login. Don't worry about the commands. Fine. Now I have enabled the telnet service on R1. Telnet service is enabled there, right? On router. To check TCP connection table, you will run command show TCP brief. Guys, is there any entry? Is there any entry? No. Now I am going to verify the connectivity between PC and router. Let me check I am able to ping router or not. So yes, I am able to ping, right? Now so IP ARP, if you will check ARP table, there will be 2 entry. MAC address of 10.1, MAC address of 10.2, right? Now I'm going to run this command telnet and 10.1.1.2. Once I will hit enter over here, see what is saying. Now I have access of R1, you can see here, right? Earlier I was in PC1, now I am in R1, router 1, right? Now I can configure R1, okay. And brother, now here if you will check, see password is not there. Let me do one thing, let me configure one password as well, enable password, or see now there is telnet session between R1 and PC1. So if you will check show TCP table, show TCP brief, so you can see there is one entry, yes or no? This is table on R1, right? There is one entry now. There is one TCP connection between 10.1.1.2 and 10.1.1.1. 10.2.2.2, 10.1.1.2 is using this port number, and 10.1.1.1 is using this port number, random port number, right? And state is what? Establish. Why guys? Because of Telnet. Telnet is a protocol which uses TCP service at transport layer. So that's why before sending actual data, it will establish a connection. Now I am going to terminate it, exit. Now again, if you will check show TCP table, see, state is what now? Time wait. Soon it is going to remove this entry, right? Soon it is going to remove this entry. After that, you will see there is no any connection, right? On the PC also. Now for the next time, again I am going to send the telnet traffic to PC, but this time before sending telnet traffic, I will capture this link. So let me do one thing. Let me capture the link. See, I have captured the link. Just wait. See, now I am able to see the traffic on this link, right? So if PC is going to send any TCP traffic, right, I can see there. So now see, from PC, I'm going to send again telnet request. So TCP brief. So now you can see there is no any entry. Now again I'm going to run telnet and 10.1.1.2. See the capturing boss. Seen message. Are you able to see on the top? First message is which message? Which type of message it is? Seen message. Who is sending? PC or router? Source IP 10.1 means PC1. Destination IP. Source port number. Random port number. Right? Destination port number. Which type of message it is? What is sequence number? What is window size? What is length? What is maximum segment size? Because this is just a header, na brother. So actually, see, when I'm going to show you the next TCP header, like TCP header in this packet, this is actual telnet packet. When we will open this one, then we will discuss it. Don't worry, right? Clear to everyone? First packet. Then guys, second message. Which type of message it is?
Sync acknowledgement.
And who is sending?
Destination.
Means router.
Yes.
Which type of protocol it is using? TCP. Source port. Well known, because telnet is sending. Destination port. Random. And this is not length. This is length somewhere. Here you can see the length. This is the length. Right. Now, third message. Acknowledgement. Who is sending? PC. To whom? Router. Source port. Same. Destination port. And if you will check the TCP table of PC, you will see same source port number and destination port number, right? Here I can run what command. So TCP brief. See, port number of 10.1.1.2, right? Sequence source, port number of 10.1.1.1, same. And then guys, after this three-way handshake, these three packets, finally router have sent their, PC have sent their first telnet request message, right? So if I will open this transport, this TCP message, right? See, is there any application layer information, guys? No. Means my data is starting from where? From transport layer, right? There is no application layer. Transport layer is generating this data. Right? But if I will open the actual telnet packet, this message, see, this is application layer, this is transport layer, this is network layer, this is data link layer, and this is physical layer. This is not OSI model, this is TCP IP model. So in TCP IP model, guys, we have application layer, we have transport layer, we have internet layer, we have ethernet layer, and frame, right? See here also, correct? now. Okay, let me open the actual telnet message. So see, you are not developer, so you cannot read the actual telnet message, right? You cannot read it. And this is again not for you as well, right? These are important for developers who is developing this protocol or managing it, right? For those, for you, transport layer is important, right? Guys, in this packet, what is sequence number? Okay, I have not discussed the sequence number in these three packets. Let me discuss that also. See, in the first scene message, sequence number is what?
0.
0. In the first packet of PC2 is, means router is what? Sequence number.
0.
And acknowledgement number means sequence number plus,
1.
right? And when PC is sending acknowledgement, sequence number is what? 1, because it is second message of scene. This is my PC, this is my router, right? So first packet scene message sequence number is what? 0. In the scene plus ACK message, sequence number is 0 because this is first packet of router, and acknowledgement number is what? Sequence number plus 1 means 1. Then PC is sending scene acknowledgement, third message, right? So means this is second message of PC, so sequence number will be what? 0 to 1. And if router need to generate reply message of this packet also, then router will give acknowledgement or what acknowledgement number? 2, right? This is how sequencing and acknowledgement number work in case of TCP and UDP. And guys, you know, while sending actual data, there is some difference between sequencing, not sequencing, in term of acknowledgement. While sending actual data, you know, let's say PC and router. PC is sending one data, sequence number 1, and size of this data is 100 byte, right? So router is going to give acknowledgement on 100 plus 1, size of data plus 1. Size of data means I have received 100 byte of data from you, like this. Sequence number will be same, like, you know, this PC and let's say router, right? Sequence number over here is 1 and size of data is 100 bytes. It will give acknowledgement on acknowledgement number 101. Again PC is going to send data with sequence number what? 101. 101. Okay. Again it will give, server will give acknowledgement on acknowledgement number what? Sequence number plus, correct. Means send me the data from 102 means what? I have received till 101. Router will give acknowledgement on acknowledgement number what? 102, because sequence number over here is 101, right? That means PC will came to know that server or router have received successfully how much data? 101 byte, correct? So this is how sequencing and acknowledgement number will work in case of sending actual data. So this is first message, router PC have sent it to router, actual telnet message, right? Okay. Guys, after that there are many more information, like if you will open TCP header here, you can see source port, destination port. Okay, leave it for now. Sequence number, and then this is raw sequence number. You will not see it on real devices, right? This is in simulation, and in YXR it will show you this also. The next sequence number is going to be what? Acknowledgement number is what, right? Raw acknowledgement number. And then we have what? Flags. So if you will open the flags, you can see there are multiple flag, 8 flags are there. So one is fin, one is sin, one is reset, one is push, one is acknowledgement, one is urgent, congestion, window reduce, correct? So these are the flags, right? Window size is there. The most important information in this header is for you is what? Source port, destination port, sequence number, acknowledgement number, and in the flag, sin flag, ACK flag, and fin flag. Clear?
Yes.
Now when we will discuss IP header, then I will show you this field also, right? For now let me close it. Okay, so you can see I have a still telnet session from PC1 to router. So still there will be what, sorry, let me configure one password here. Enable password Cisco 123. Getting some noise from somewhere, please. So that's why you can see session is still there. Can I move? Now see the next headers. Here it is. Next header is UDP header. Guys, in UDP header there will be very less information. You can see source port, destination port, length, checksum, and then your actual data. Okay, so this is one more benefit of UDP, that UDP is going to add very less extra information. Means size of this header will be lesser than the size of TCP. Correct? So total length is what, 32 bits. So 32 plus 32, 64. Total size of UDP header is what? Only 64. If I will talk about the total size of TCP header, so 32 multiplied by 30, 32 plus 32 plus 32, 32, 32, right? You can calculate the size. It will be around 160. Okay. Then guys, we have what? IP header. At network layer, which protocol is working? IP protocol, right? So IP protocol is going to add IP header. With the help of IP header, it will provide source IP and destination IP. But again, in the IP header, there are many more fields. First field is what? Version. So we have two version in IPv4. Sorry, in IP addressing. We have two types of IP addresses in the market. One is IPv4 and another one is IPv6. Now we are going to talk about the IPv6, IPv4, and later on we will discuss IPv6 as well. Okay, because IPv6 is in your syllabus. So this version field is going to identify the version of IP address. Then again header length, then priority, this is used for quality of service. Then total length. Total length is unique field over here. So total length means length of header plus length of data, and header length means length of header only. Getting my point? The identification field, so there is some use of identification. You will see router can also divide, you know, large size of data into a smaller part, right? Like transport layer is doing. So we will see when router will divide the data into multiple parts, then how other devices, receiver devices, are going to identify that data. For this reason, we have identification field over here. Again, we have flag field, then we have fragmented field, right? Then we have TTL, time to live. Then we have protocol, header length, source IP, destination IP, option, and then your actual data. So see here in this header, TTL field is, guys, very important. VVI. Fragmentation field is also important, right? Checksum you already know. Protocol field is very important, very important. Identification field and fragmented offset, these two are also important, right? Apart from it, for you, rest field are not important, like version, right? Header length, priority, total length. These are, you know, like okay, we know that there are four fields on the top, but use of these four fields are very clear. Like priority means giving priority to something, prioritize the data. For that we can use this field. This is 8 bits information. Then we have header length, 4 bits information, version, 4 field information, right? Then total length, 16 bits information, identification, 16 bits information, flags, 3 bits information, fragmented offset, 13 bits, TTL 8 bits, protocol 8 bits, source IP 32 bits, destination IP 32 bits. So size of IPv4 address is 32 bits. Fine. So let me discuss all fields guys, important fields one by one. Okay, let's start from the protocol. Okay, so see, what is the use of protocol field? I'm going to design one small network over here, two computer there, PC1, and let's say this is server. PC, are you getting bored? Server IP address over here is 10.1.1.2. IP address over here is 10. On this server we are running some services, right? Let application layer, at application layer there are some protocols running: HTTPS, DHCP, Telnet, DNS. Let's say these services. Fine. Okay. At transport layer both protocol is working. At network layer IP protocol is working. Okay, so this thing is clear to you. Now if this PC want to access, let's say, HTTP service, so application layer is going to generate what? HTTP data. Then it will hand over to transport layer. Now what transport layer will do over here? It will add source port, destination port. Source port will be random port number, destination port will be what? 80. Let's say this is HTTPS. Destination port will be what? 443. Source IP will be what? 10.1.1.1. Destination port will be what? 10.1.1.2. Okay. Leave source MAC and destination MAC for now. This is the data that PC1 is going to generate. When server will receive it, right, it will receive at layer 1, then it will hand over, layer 1 will hand over to layer 2, layer 2 will check source MAC, then it will hand over to layer 3. Now layer 3 is going to check which protocol is working at layer 3 guys? IP. And there are many more protocol, like at transport layer TCP and UDP protocol is working, right? At network layer IP, let's say EIGRP, OSPF, these protocols are working, right? And leave data link here for now. So IP protocol will receive this packet, then IP protocol will check what? Destination IP. So destination IP, it will compare destination IP with their own IP address, both are matching, right? Now guys, here IP protocol have checked that okay, our destination IP address is matching. Now responsibility of IP protocol is what? To remove this extra information at layer 3 and to hand over the actual data to layer 4. Correct? Now how IP protocol will came to know? Because at transport layer there are two protocol, one is TCP, another one is UDP. How IP protocol will came to know that I need to hand over the actual data to TCP or UDP, segment to TCP or UDP? That's why we have what? Protocol field in the IP header. We have what? Protocol field in the IP header. So in the IP header there will be one protocol field, right? There will be port number of either TCP or UDP. Maybe port number can be of EIGRP, can be of OSPF. Let's say if there is port number of TCP, then IP protocol will come to know that, oh, the actual segment is for whom? For TCP protocol. If there will be protocol number of EIGRP, then it is going to hand over whom? EIGRP protocol, right? So how network layer is going to identify, or you can say IP protocol is going to identify the upper layer protocol. For that we have what? Protocol field in the IP header. And as I told you, it is very important, right? So when we will discuss the practical of it, you will see in the entire CCNA we will be talking about it, protocol field, right? So every time whenever we will start the protocol, we will discuss what is the port number of that, protocol number of that protocol. This is the first thing that you will learn in the protocol. So like if you have knowledge of TCP and UDP right now, So please check what is the port number of TCP and what is the port number of UDP. Sorry, not port number. Again, I am saying port number because since last few hour I am just speaking TCP and TCP only. Okay. So check what is the what is the protocol number of TCP and what is the protocol number of UDP. Okay. Then guys, what we have TTL value. TTL, time to live. So time to live. Okay. So just try to understand one more example over here. Then we will come to this diagram again. Before that, let me design one more scenario here. Let's say I have network. In my network there is one switch. That switch is connected with one router, and this router is connected with one another router R2. R2 is connected with one another router R3, and R1 is connected with one more router, that is R4. Like this. This is my topology, and then I have one more network over here, one switch. Then there are some users. Is design clear to everyone? Is design clear?
Yes.
Okay. Now let's say here I'm running network 10.1.1.0/24. Here I'm running network 20.1.1.0/24. Fine. So by default, slash, this is CIDR value. We will discuss in the IPv4 addressing. After OSI model, we are going to start addressing. Okay. First we will see MAC addressing, then IP addressing. Don't worry. Okay. Let's say this router have one instruction. Then brother, whenever you need to forward traffic to 10.1.1.0 network, you will forward traffic to router number 2. And let's say I have given, by mistaken, engineer have given same instruction to router number 2 also, that whenever you need to forward traffic in this network 10.1.1.0 network, please forward the traffic to router number 1. See, instruction means commands. We have run the command, we have configured R1 in such a way so that R1 will always forward traffic for this network to router number 2, and R2 will always forward traffic for this network to router number 1. Now just assume if router 1 will receive one traffic where destination is 10.1.1.1, what will happen, brother? R1 will forward it to router 1, router 2, and router 2 will forward it to whom? Router 1. Yes or no? Because of one miss command, right, on router number 2. See, there is loop between R1 and R2, because for lifetime R1 will be sending this packet to R2 and R2 will sending this packet to R1 for lifetime. No one is going to stop this packet without time to live, without TTL, right? So guys, because of misconfiguration, because of link failure, in real time you will see in your network loop will form, right? Sometimes loop can form in my network. In the switching also, like if you are connecting switches like this in the circular, then there is chance of loop, and 100% loop will form over here between switch 1 and switch 2, 3. That's why here we are using a protocol in switching, that is STP. Height of switching, very important protocol in switching. STP, spanning tree protocol, which is responsible to avoid layer 2 loop. This protocol is responsible to stop loop on switches. But what about the router? How we will prevent the loop on router? With the help of, guys, TTL. So in IP header, IP protocols are going to add what? TTL value. So let's say in the packet TTL value is what? 255. By default TTL value will be 255, but for now let's say TTL value is what? 10, right? And always keep in mind, whenever a packet will cross the router, TTL value will be decremented by 1. Whenever a packet will cross a router, TTL value will be decremented by 1. So when router 1 will forward this data to router number 2, it will decrement TTL by 1. So TTL will become what on router 2? 9. When router 2 will forward it to router 1, again TTL will become what? 8. When again router 1 will forward to router 2, TTL will become 7, right? Then 6, then 5, then 4, then 3, then 2, then 1. On router number 2, router 1 is receiving this packet with what TTL value? 1. So on R1, TTL value is going to become what? 0, correct? So whenever a router will receive data with TTL value 0, it will discard it. What I'm saying? Whenever a router will receive a data with TTL value 0, it will discard it. So now where is loop? Loop has gone, yes or no? So TTL value, time to live, is a field in IP header which is used to avoid layer 3 loops. How? Whenever a packet will cross a router, TTL value will be decremented by 1, and on a router, when TTL value will become 0, that router is going to discard the packet. Clear? So now loop is removed, na brother. Let's say TTL value is 10. So after 10 packet, TTL value will become 0. R2 will drop the packet. If there is no TTL, then both router will be forwarding packet to each other for lifetime. Getting my point? Okay, so to avoid, and let's say guys, in this entire network there is loop. Like R1 is forwarding traffic to R2, R2 is traffic forwarding that traffic to R3, R3 is forwarding that traffic to R4, and again R4 is forwarding same traffic to R1. Again, this is what? One kind of loop. So because of misconfiguration, you will see sometime this kind of loop in your network. Loop will form, and whenever you will see the loop, CPU utilization of devices will start increasing, because frequently both devices are performing encapsulation, decapsulation. When device is receiving a packet, it is performing what? Decapsulation, right? When it is generating, it is performing what? Encapsulation, means adding extra information. So see guys, in very short terms of time, it is doing these works and lots of works. Okay, so that's why we have TTL field in the IP header. Okay, so see again the IP header. Now version field is clear, header length is clear, priority is clear, total length is clear, identification leave these two for now, and time to live is clear, protocol is clear, header checksum is clear, source IP is clear, destination IP is clear, and data is clear, right? Where is header checksum? This one. Again, it will calculate the hash value, na? It will calculate the hash value by putting the data in algorithm, right? It will add that hash value with data, and when receiver machine will receive the data, it will also do same thing. After that, it will match hash value is matching or not. If hash value is matching, that means no one have modified the data. If hash value is not matching, that means someone have modified the data. Guys, I am teaching you, I am speaking single word multiple time just for one reason, so that you guys can just learn it, right? Not remember it, because these things is going to help you to learn any other technology. Without this knowledge, right, it's not possible to learn CCNP, SD-WAN, cloud security, any other technology. But if these things is clear to you, right, I'm guys damn sure anyone can learn SD-WAN by yourself, by their self, right? If your basic is clear, because everything is based on basic only. So that's why I am speaking same word again and again. Leave it if anyone is getting bored. Okay. Now if you can read about these fields here, you have short information. Okay. Like for now you can check the identification field. What is the use of identification field? If the IP packet is fragmented. Now if you are thinking what is fragmented, so guys, when transport layer is dividing large size of data into a smaller part of data, that process is called segmentation. And whenever a router is dividing a large size of data into a smaller part of data, that thing is called as fragmentation. Okay, so segmentation will be done at layer 4, fragmentation will be done at layer 3. Router works at which layer? Layer 3. Remember, day 2 class,
Packet.
right? Okay, so when you will fragment the data, when router is going to divide the data, then each fragmented packet will use the same 16 bits identification number to identify which IP packet they belongs to. Like let's say a router have divided one data into three part. So on these three parts it is going to put one number, 16 bits value, right? So let's say here number is 10, here number is 10, here number is 10. So receiver machine will came to know that these three packets belongs to a single packet. They can now combine it. A router, let's say I have two router R1 and R2. Guys, R1 interface MTU is 100 byte and R2 interface MTU is, let's say, 1500 byte. So if R1 need to send a data whose size is, let's say, 1000 bytes, so only R1 need to divide it into a smaller part. R2 don't need to divide it, right? R2 can forward the entire data at a time because their MTU is 1500 byte, right? So if R1 is breaking the data into multiple part, R2 is going to combining it. First it will combine it, then it will forward from their interface. Fine. Then flag, as we have 3 bits, first bits will be always, the second bits is called, right? If you want that router should not fragment your data, router should not divide your data, you can turn on these bits. If router is receiving a data with don't fragment bits on, it will came to know that I am not allowed to fragment it. So router will simply drop it, right? If router is receiving a data and that router don't have capability to transfer the same size of data, then router can drop it, but router is not allowed to fragment it. So for that reason I am using this bit, right? So like I think in the here also we can check this thing. If I am pinging 10.1.1. let's say 2, then let me put question mark here. Here I can define the size. Yes, see, don't fragment bits is there na? So I can say don't fragment. If I will ping like this, then router is not going to fragment my data. Getting my point? Then guys, what we have last bits, MF, more fragment. If this bits is on, that means this data is fragmented. Whenever router will divide a data into a smaller part, it will on this bit. If a router is receiving a data with this bit on, then router will come to know that this data is fragment data, not the actual data, right? This is, yes, modified, not modified means what, changing something, but here just we are dividing it, right? Making multiple from one. Okay, so don't fragment, more fragment field is there. Then segment offset, it is 30 bits, specify the position of IP packet. So don't worry for now. When I will discuss the packet flow, that time I will make you understand this point. If anyone is not getting it, don't worry. Then what we have, time to live. So time to live is clear. Then protocol. Hope protocol is also clear to you. Because what I will do in the one lab, I am going to divide the packet. I'm going to tell to router to perform fragmentation. I will generate that size of data that router have to do fragmentation, right? And then I am going to show you the capturing of that also. Okay, don't worry, wait now. Then there is difference between segmentation and fragmentation. Before discussing the difference, let me show you the IP header. See guys, in the IP header, yes brother, here we can discuss now again the protocol field. See, I'm going to open the IP protocol. See, first field is what version, which version I am using. What is the length, header length? 20 byte. Total length, identification, flag. Is it fragment bit? It is fragment data. No, because this bit is on. If fragmentation is allowed for this data, but yes na brother, don't fragment bit is off. Where are you? Okay, then what we have? So by checking this field, brother, IP protocol. Where is IP protocol? Here is IP protocol. IP protocol is going to check this field to know to whom I need to hand over this data. This is actual data for network layer and this is complete header. Yes or no? Right? So by checking this field, IP protocol is going to come to know I need to hand over this data to TCP protocol. Clear? TTL value. Again, TTL value depends on operating system. This is TTL value in Cisco IS. In Windows operating system, you can check what is the TTL value. In Mac operating system, in Linux operating system, you can check it. Any question, guys, in IP header? Okay. Then transport layer. How transport layer will come to know? The C for transport layer actual data is what? This one, right? And this is what? TCP header. This is TCP header, right? So transport, how transport layer will come to know that I need to hand over the actual data to telnet protocol. Yeah, if you will open that reply packet from the router, you will see destination port there. This is packet from 10.2. Yeah. So this port, destination port in the TCP header is going to identify upper layer protocol. Protocol field in the IP header is going to identify the upper layer protocol, right? If I will open any UDP packet, see on the PC, I'm going to send one UDP packet. So for UDP packet, simply I'm going to do one thing, interface f0/0, say no IP address and say IP address DHCP. See the discover message. Discover message somewhere. Yeah, are you able to see the discover message? This is UDP based. So at layer 4 you can see protocol is what? UDP. So in the IP header protocol field value is what? 17. Means 6 is the protocol number of TCP and 17 is for UDP. Like this you have to learn the protocol of EIGRP, OSPF, BGP, right? Multiple protocols are there and we are going to learn those all protocols, but for all application layer protocol, guys, right? For all application layer protocols, port number will be always either 6 or 17, correct? For all application layer protocols, like for DHCP, for DNS, HTTP, Telnet, SSH, correct? Okay, and then guys, finally we have what? Layer 2 Ethernet header. So if you will open Ethernet header, you can see there are three information only: source MAC, destination MAC, and type. So again, type field is going to identify the upper layer protocol, right? Type field will tell to Ethernet that to whom you need to hand over the actual data. So what is type code here? 0x0800. This is type code of IPv4, right? Sometime in the Ethernet header you will see type code is 0x0806 because this is type code of ARP protocol. ARP protocol. Address resolution protocol, brother. See, if I will configure one IP address to my machine. IP address 10.1.1.1, 10.1.1.1, 255.255.255.0, and so IP interface brief. Okay, IP address is there, and so IP ARP. Is there any entry for destination MAC address, means for 10.1.1.2? No. So if I will ping 10.1.1.2, first this machine will generate what? ARP, because destination MAC is unknown. So it will, layer 2 will call to ARP protocol, na? Come brother, please find the MAC address of 10.1.1.2, yes or no? So let me hit enter over here. See, ping is working, first packet is here. See, this is first ICMP packet, ping packet, but before that you are able to see two packet. First one is ARP request, second one is ARP reply. This message is what? Who has 10.1.1.2? See the message, who has 10.1.1.2? Means who is using this IP address? Tel2 10.1.1.1, right? So don't worry, we will discuss the ARP protocol also, guys. But as I told you in I think in day 1 or in day 2, that ARP, whenever a machine don't have MAC address and they have IP address, it is going to generate ARP to resolve. So simple word, what you can say, ARP is a protocol which is used to resolve MAC address from IP address. A machine will generate ARP request, and the destination machine, that machine who is using that IP address, will generate the reply message. In the reply, it will share their MAC address. That's it. So if you will open this ARP message, you can see type code is what? 0x0806, right? So if at layer 3, let's say not IPv4 protocol is working, IPv6 protocol is working, then there will be type code of IPv6, right? So guys, what we learned, what we understood, that in data link layer, at data link layer, means in Ethernet header, there is one field, that is type field, which is going to identify the upper layer protocol. In the IP protocol, in the IP header, there is one field called protocol field, that is going to identify upper layer protocol. And in the TCP or UDP header, there is one field called destination port, which is going to identify upper layer protocol. Am I right? And everyone is agree with this or not?
Yes.
Yes, na? Now you can read the difference between segmentation and fragmentation. Segmentation means what? Dividing big data into smaller data is known as what? Segmentation. And fragmentation is also what? Same, dividing big size of data into a smaller part of data. But difference is here. It works at layer 4, means transport layer. It's work at layer 3, at network layer, right? Segmentation will done with the help of MSS, maximum segment size. What should be the segment of size? On the basis of that, transport layer is going to divide a large size of data into a smaller part, right? We discussed this many times. What I am saying, how transport layer is going to divide large size of data into a smaller part of data? On the basis of MTU. First it will negotiate the minimum MTU, right? According to that, it will just decide what will be the size of my segment. That is called what? MSS, maximum segment size. What can be the maximum size of a segment? And this is excluding IP header and TCP header. It is excluding IP header and TCP header. So segmentation is done on the basis of MSS, and fragmentation is done on the basis of what? MTU. If router is not able to forward the data, then router will divide it simply. So it totally depends on what MTU directly, maximum transfer unit. By default MTU is 1500 byte. By default MSS is what? 1400. Now why? Tell me why MSS is this one, 1460? Because see guys, a router interface have what capability? To transfer 1500 byte data. So if transport layer will generate, it will divide the data into this amount, then what will happen? It will add 20 bytes TCP header and 20 bytes IP header. So now total size of data is what? 1500 byte. So this is also based on what? MTU only. So from the MTU, if you will subtract what? Your your headers, then you will get what? Maximum segment size. Okay. And now next point, segmentation is done for layer 7 traffic or for layer 4 traffic, right? Segmentation will happen for which type of traffic? For layer 7 or layer 4 traffic? Fragmentation will done for which type of traffic? For layer 3. Layer 3. Because see, if a router is receiving a traffic, guys, just try to understand, their MTU is 1500 byte. This is very important. Please pay attention. Router MTU is 1500 byte. So if a computer is going to send the data to router, this computer have already knowledge na, that what is the MTU, minimum MTU between source and destination. On the basis of that, transport layer will divide the data. So router never need to divide the data which is coming from transport layer, because transport layer have already divided it accordingly, according to the requirement, correct? But what
Yes.
about for the traffic which will generate at layer 3? Because the traffic which is going to generate at layer 3, there is no transport layer now. So layer 3 can generate any amount of any size of data. For layer 3, router have to do what? Have to divide only. Yes or no?
Yes.
So hope this is now clear to you why fragmentation is going to happen on layer 3 and for layer 3 traffic, and segmentation for layers 4 and layer 7 traffic. Now guys, some application layer protocols. 1 minute. First of all, I have to check the syllabus one more time. Okay, so okay, this one we covered this in day 1, this covered in day 2, in day 3 we covered OSI model, in day 4 we covered the headers as well as TCP IP switch, and then we are going to understand some application layer protocol. So tomorrow we will discuss application layer protocols. See guys, how many application layer protocols we need to discuss. HTTP, and what you need to keep in mind about this protocol. First thing is port number. What port number this protocol is using. Then what service this protocol is using at transport layer, TCP or UDP. And then what is the function of this protocol. Got it? Only these 3 things you need to learn about each protocol. And some protocols are there, right? About that you have to learn how it's work as well, like telnet, SSH, this protocol you have to understand the configuration also. But for these protocols, HTTP, HTTPS, just you need to keep these 3 things in mind: port number, service at transport layer, and the use. Then guys, we have telnet, so we will discuss telnet also tomorrow. Then SSH, then FTP, file transfer protocol, TFTP, then NTP, then DHCP, then DNS. So tomorrow I will finish these all application layer protocols, and in next class after tomorrow we will start IP address. Not IP address. Before IP address we will discuss what? MAC address. We will start means after tomorrow after tomorrow we will start IP means addressing, network addressing you can say. Fine. Yeah.